Sometimes the most powerful idea in a book isn't in the middle, it's hiding right there at the very end. And that's exactly the case with Steve Pereira's Flow Engineering. We're going to unpack a few simple but seriously powerful concepts from its final chapters that could completely reframe how you look at your work, your team, and your results.
And it all comes down to this. The entire philosophy of flow engineering, the whole thing, can be boiled down to these three questions. I know, they seem almost too simple, right? But asking them over and over again creates this powerful loop of improvement that can genuinely transform an organization.
So here's our game plan. We'll start with the heart of it all, those three questions. Then we'll get into how you can actually measure the health of your system. After that, we're going to zero in on the single most critical metric, uncover a hidden cost that's draining your team's efficiency, and finally, wrap up with the absolutely astonishing payoff you get when you nail this.
Right, so this is the core loop. Think of it like a self-correcting system. First, you define what's valuable. Then you get super clear on what's blocking you from getting it. And then you take action to improve the flow. And then you just repeat it. It becomes this constant engine for progress. And here is the most important part. You don't need a huge budget or a big green light from the executives to start. The change begins with a mental shift. Just by framing your meetings, your conversations, and your own work around these three questions, you're already on the path. Honestly, the hardest part is just starting to ask.
Okay, so once you're asking the right questions, you need a way to find some real objective answers. And this isn't about building some crazy, complex dashboard. It's about using some surprisingly simple math to get a read on the health of your workflow. And it all kicks off with a fundamental idea from something called queuing theory.
This is Little's Law. Now, it might look like a throwback to high school algebra, but it is an incredibly powerful lens. It connects three key variables. First, you've got L, which is just the average number of things you're working on at any one time, your work in progress. Second is lambda, which is your completion rate or throughput. And third, W, the average time it takes for something to get all the way through your system. That's your lead time.
So, what does this look like in the real world? Well, the book has a great example. Imagine you glance at your team's workflow, and you count about 15 items being actively worked on. That's your L. You also see that the team finishes about 60 items every month. That's your throughput, lambda. With just those two numbers, we can flip the formula around to figure out W, the average time each item takes.
The math is dead simple. 15 items in progress divided by 60 completed a month gives you a quarter of a month or about 7.5 days. And you think, okay, that seems pretty reasonable. A week and a half to get something done? But this is where Little's Law delivers its first shocking insight.
6.5 years. That's the hidden truth. If your team has a backlog of 200 items and your system just keeps chugging along at the same steady rate, it will take over 6 years just to clear what you have right now. This is the kind of gut punch realization that simple math can give you. It shows your system might be stable, but it could be stable in a way that just guarantees failure.
And this leads us directly to the single most important metric of all, time. But not just any time. We have to be crystal clear about what we're actually measuring, because it is dangerously easy to fool ourselves by looking at the wrong thing.
Here is the classic mistake that we all make. We focus only on the active work time. So let's say it took 2 months to develop a new feature. We pat ourselves on the back. Great, 2 months. But what if that request sat in a backlog for 8 months before anyone even picked it up? From the customer's perspective, the total time wasn't 2 months, it was 10. That waiting time is absolutely part of their experience.
The book gives 3 really profound reasons why focusing on this total lead time is so vital. First, you can't make more time. It's always ticking away. Second, because it measures the entire journey, it forces different departments to actually talk to each other and collaborate. And third, it measures the full loop, from when a customer asks for something to when they get value, which is your fastest path to learning what works.
As the book puts it so well, time is the one dimension of work you have the least control over. Lead time is the most complete representation. By measuring it, we are forcing ourselves to honestly confront the reality that our customers are always waiting, and every single moment of delay has a real cost.
So, we've seen how time gets wasted just sitting in queues, but what about the time that's wasted doing things over again? This is what we can call a quality tax. It's this hidden cost you pay every single time work has to move backwards instead of forwards.
The metric for this is called percent complete and accurate, or percent CNA. The idea is really simple. For any step in your process, what percentage of the work that comes to it gets through correctly on the first try without being sent back for fixes or for more information? It's a direct measure of your first pass quality.
And this is where things get a little scary, because these quality issues compound. You might think, okay, a 90% quality rate in planning, that's pretty good. But then maybe the build stage is only 50% accurate and testing catches 70% of issues. Because these steps all depend on each other, you have to multiply the percentages. And suddenly, the chance that a piece of work will flow all the way through without any rework is just 31.5%.
And here's the reality check. The book points out that for many teams that are just starting to look at this, it is not uncommon for that final rolled-up %CA number to be less than 5%. Just let that sink in. That means 95% of the effort is creating rework, delay, and frustration. It is a massive, hidden source of waste.
All right, so we've identified these huge opportunities to improve by managing our work in progress, focusing on lead time, and boosting our quality. But does it actually pay off? Let's get to the bottom line, the return on investment.
First, let's look at the investment. This table from the book estimates the cost of doing the core flow engineering exercises for a team of 8 people. We're looking at a total of 13 hours of focused work up front, costing about $18,000 for the year. It's a tangible, pretty reasonable investment.
Now, for the return. Let's imagine the same team delivers about $4 million in value every year. If these simple exercises lead to even a conservative 20% improvement in throughput, meaning they just get 20% more valuable work done, that $18,000 investment unlocks $800,000 in annual benefit. That is a 44 times return on investment. It's just astonishing leverage. I mean, even if you cut those benefits in half or you double the costs, the business case is still overwhelmingly positive. Investing just a little bit of time to improve how you work pays for itself many, many times over.
So, where do you start? The book gives a beautifully simple way in. You don't need permission for this. In your very next meeting, try to sketch out a simple map of the desired outcome. Map out the flow for a task you do all the time. Find one small delay, one piece of waste that you can fix yourself. And really importantly, celebrate that small win.
And that leaves us with a final question for you. Forget about trying to fix everything at once. Just think about your own daily work. What is one frustrating delay, one little bottleneck that keeps popping up that you could just start to measure tomorrow? Because as we've seen, what gets measured gets managed, and what gets managed gets improved.